continue solving uh, problem-based questions using if-else conditions. So this one is for if-else. So let's take a look at a couple of questions. Those are if-else based and they are problem-based. So let's say, look at the problem first. The problem is operator rely on indicator light to decide what action to take. Misinterpreting the light color can lead to unsafe operation. So you need to automate this, right? So automate by how, and this is how what it said this here, how we can automate this. And you need to first, obviously the problem need to convert it into steps, and then step becomes solution. And today purpose is to actually teach you how to program different steps. I mean, this is pseudocode. This is called pseudocode, writing statements to solve a problem. So you have a pseudocode here. All I need is copy paste this into the Tony and step by step program pseudocode. So what are the steps? Write a Python program that accept the indicator light as a input. So you need to say enter indicator light color, right? That's what it says. Accept the indicator light color as input. So what we do is we say input, right? Color, right? It's a color, right? So we say it's color is equal to, I'm gonna give you a little bit more space so that we can see the difference between the statement and the Python code. So input, because it's a color, so you don't have to make it integer. It's gonna be pure string, right? So instead of accept, you say enter the indicated color, and then to make a little bit nicer look, I put this colon there, so a little space, so when it enters it gives you space. So this job is done. What is display the correct instructions, right? If it is red color, stop. If it is yellow color, get ready. And if it's green color, go. And then display an error message for invalid input. If any color beyond that, it is invalid. It's a simple case of if else. So what I do is I say, and let's keep, and we also say enter the color light color in caps, all caps, in capital letters, so that it's all it's told to the guy that enter in capital letters only, so we don't have to compare smaller letter, so we all compare caps. So if color equal, what is the first one? Red, right? This is red one, right? The top one. Do what? Stop, right? So we say print stop. Here we go, stop. And then second is also a elif, right? If color is yellow, so we can use if as well, like this, or you can use else as well. So elif is better here. If elif color is equal yellow, we put all in caps, right? Yellow. Then do what? Simply print. What do we supposed to print as yellow? Get ready, right? Get ready. Here we go, get ready. And the third one, the last one, is green, right? So it's again elif color is equal green. All right, and do what then? Simply print go. That's it. And finally says if none of that is there, simply print an error message, because that will be invalid input. If none of the green, red, if anything you enter beside that, it'll be an error. So you say else error, right? Else error, because if this is not red, this is not green, this is not yellow, it's supposed to be an error, right? Oh, I say error invalid input, because that's what exactly it said there. I see here display an error message for invalid input, so I say error invalid input. So now one by one I followed all the instructions without using my brain. I simply read and did, right? So here accept the indicator color, I did that, right? Then I displayed the correct instruction based on red, yellow and green, and displayed error using if elif ladder, and it's all done. And I can now check my program, which will be working perfectly, solving the problem of a guy who is standing at the maybe middle of a road, and he just wants to automate the lights. So I say indicate the letter is yellow. What you supposed to do? Yellow. Get ready. If letter is red, what are you supposed to do? If the letter the color is red, stop. If the color is green, what are you supposed to do? Go. Okay, and if I put any other letter, maybe I say pink, this is the wrong color, invalid input, or even any other input. I may be putting an invalid input like this, it will say invalid input, right? So that is question number what we did. Let's move on to the next one. Easy peasy, wasn't it? Like, and you had to use obviously elif ladder for that one. Let's look at the second problem. Is performance results are often misclassified when percentages are interpreted incorrectly. When you interpret percentage incorrectly, your performance results are wrong. So what you're supposed to do, accept percentage value as input, classify performance poor, satisfactory, and excellent, and display error if the percentage is below 0 and above 100. So we it doesn't tell us what is poor, what is satisfactory, what is excellent. We will decide ourselves, right? So what we need to do is, this is very simple. Again, we just need to use if else ladder, same way as
Can I do it with you, doctor?
yeah, you can, of course. Why not? I like volunteers always, right? So
Yes.
let's change the existing code. Shall we change the existing code with this? Huh? It's easy. It's the same structure, isn't it? Eh? So we can change the existing code. So don't have to write the code again because it's the same structure. If else, first we will just what we'll do is, instead of color, that will be what, percentage of what, percentage of, these are marks, or you want to call it percentage, just percentage per cent.
Yeah, but you'll need to put eval because it's numbers.
Okay, we'll put eval, no problem. We'll take your device, we'll put eval, it's a number. We'll put eval, and then we ask the user enter percentage value. That's it. No, don't have to give the big message. We say enter percentage
No,
value.
actually, you can put only input because there is no calculations.
Yeah, that's true as well. Yeah, but yeah, we can do that actually because there's no calculation. That's true. Let's not do what we're not supposed to do, right?
Yes.
Okay. And if percentage is equal to, how much you wanna give poor?
Excellent above 80.
Oh, I tell you what. There's no calculation, but there's a comparison. You have to say above it, which means percentage greater than percentage less than. Let's start with the excellent, right? If your percentage is greater than 80, that's excellent, right?
Yes.
So, but the problem is, it's greater than only work with the integer variable, so you need eval. You can't do eval with a string. You can't say greater than 80 as a string.
Okay.
Yeah, so you need the eval. I put eval
You
back
see
there.
why why we need Tony in the test.
No, it's nothing to do with the Tony. Need to know. This is something you have to remember. This is a principle. Principle you have to remember that if it is a greater than or plus minus, it's a eval. It has to be an integer value. You can't do with a string. Can you do greater than your name? No. No, it has to be a digit. Digit has to be integer. So here it's going to be excellent, right? Excellent. Then we can copy paste this and do the elif.
But put less than 100, doctor. Less than or equal 100, I think.
Yeah, because we gotta do invalid as well, isn't it? And then we say percentage and percentage percent is less than or equal to 100. That's
Yes.
very good. That's very good because that's why we'll know it is within the limit. And elif.
Doctor, do I have to do elif or can I do if?
If you do if, it may lead to a problem. Let's do if first. Let's do if. Then you have to do L at the end. I mean any value that is, well, you can do all if as well, but better to do elif here.
Doctor, if I have multiple ifs, I can use if at the first line and the second, third, or any other line. I have to use elif, right?
Actually, you can do whole thing using if as well. Let me show you how. If
I'm talking about generally.
generally last line is else. Yeah, elif. Last line is else.
No, I mean like first line if, the rest is elif.
Elif, yeah. And if you want to use just else, that has to be the last one. Okay.
Okay.
And percentage is, let's say percentage is greater than 70, and percent is less than what? Less than or less than uh, we,
Doctor, here we choose the numbers, right?
yeah, we say greater than or equal to 100. Yeah, we choose the number, we don't have to, we choose a number ourselves. So greater than or equal 70, yeah, greater than or equal 70 and less than 80. Yeah, so you don't repeat the numbers. For example, if it is 80 and above and 100, that is excellent. But if it is less than 80, which means 79, or greater than 70 and equal to 70, between 70, 71, up to 18, 79, that is what do you want to call it? What do you want to call it?
Satisfied.
Set this.
But no, doctor, put above than 60.
All right, let's do
Because-
above than 60. Yeah, and then below
No,
60.
equal 60 even, doctor.
Huh?
Equal 60 will not be fair. Yeah, equal. Yeah.
That's satisfactory, huh? Equal.
I
yeah.
thought only you put greater
No,
than.
I said equal. And then you have poor, which is
You can put else, I think.
no, but I can't do else with that. I'll tell you why. Because either you do if, elif, else. If you do else here, right? That will be right now. It's gonna catch.
Print invalid or something like.
No, not invalid. Else
Or
is,
error.
we still have a poor. We still have a poor.
Ah, okay, fair. Okay.
What is poor is percentage is greater than or equal to 0, huh? And percent is percent. What is the variable percent here, percent as well, and a percent is less than 60. Yeah, that is poor. Yeah. But if you want to do invalid, huh? If you want to do invalid, that would be again with the if. Then you have to think about it, right? You can't do else if. You have to do, or else you can't do else. You have to put a condition for invalid as well. If this is less than, if it's less than 0, or percent is here, you can't say and, all right, or greater than 100, that is invalid, right?
I mean, you can't put else print invalid.
Else is if you use if elif, then you can do else.
Ah, okay.
But you didn't use that, so you have to now literally find it out. Invalid. Okay, that's the difference. But I wanted to show you the difference between, and this is all good, right? Error is if the percentage is outside. Yeah, it's gonna say invalid, right? Percentage invalid, percentage. Okay, now if I run this, it's gonna give me exactly what I'm looking for. For example, if I say 60, it will tell me satisfactory. Yeah, if I say 40, it say poor. But if I say 101, it will say invalid. See?
So, doctor, we can use if instead of elf.
Yeah, you can, but then you have to put the condition at the end as well for invalid as well. But it's easier if you say elif, else. You don't need to do elif. You just last you say else, right? And that's it. You don't need to put the last condition. Then
What's the big difference, doctor?
difference is you don't have to figure out yourself at the last one. Last one you just say else because everything is else is covered. And now it will be just if I say 101, it say invalid. Yeah. If I say -1, it will be still invalid. And if I say between 100, let's say I say 50, it will say poor. See?
Else is easier. Elif.
Your
is
choice.
easier.
Your choice. You could do
Okay,
it.
it's clear, doctor.
All right. Let's move on to the next one then. Question number 9 now, right?
Yes.
9 is about similar question. It says training score must be validated before grading. Incorrect validation can result unfair. So you have to validate, you have to make sure your score is between 0 and 100. 0 and 100, that's how you validate it. And if it is somebody enter, let's say score 101, it's invalid, right? So it's the same thing what we did. and easier actually. This question is easier than the last one. How? Let me show you how. You copy this, you paste this, and you put it here like this, and one by one again validate the entered score. First you need to get the score entry, right? Score is equal to integer input, because you need a score before you can validate it, right? And say enter score, enter score, that's it. And then validate it. Validate it means it has to be between 0 and 100, and you can even say here enter score from 0 to 100, because it's not between, from 0 to 100, right? And then validate means you check if score is greater than or equal to 0 and less than or equal to 100, that is a valid score, right? Yeah, you can print valid score. You don't have to print valid score, okay? If that is not between that, you say else, right? You can print here, we'll do more after validating, but if it is not valid, then you simply, what will happen is invalid score. So what it'll do is, when you take the score, if it is greater than or is equal to 0, less than 100, it will come here. It will come here. Otherwise, it'll go to the else part and print invalid. Now, when it comes here, what we need to do, we need to determine pass or fail, right? And assign a grade using nested if. So we have to do nested if and clearly display the results. So within that, we use if again, that's nested if. If score is greater than or equal to 60, right? What is that? Print pass, right? That is pass, isn't it? Pass, right? Else, it will be print fail. That's it. We're doing first we validated it, then we.
No, I think, doctor, if you will put elif fail and then else if it's not between 0 and 100.
Well, but it said use nested if, so that's how we use nested if. We don't need anything else in nested if because you already validated. Listen, because you validated using first if.
Oh, okay. But can I delete this if and then write if and then elif and then else?
No, because that's not nested. It literally said use, look at this question. It says use, you need to read the question. What it says, you have to do that.
So nested, what it means?
Nested means if within if. If within if. So this is if, right? And else. And then you put another if else within if else. That's nested. So you, first if you use to validate it, second if you use to determine the score within validation. Yeah? And you display the result very clearly. So if I run this, I will have 100% accurate score. Look at this. If I say here, sorry, there is an error, a syntax error. Let's see which one is that. Oh, here, I need to put a score here. Score. I forgot the score there. Okay, look at this. If I put here 101, right? So what will happen is, it'll come here this line, and because it's greater than equal to 0 but not less than equal to 100, it's 101, so it will not come here. It will simply go to the else part and say invalid, right? And that's what will happen. Look at this, invalid, right? See, it printed invalid. Now if I put a valid score, let's say I say valid score as 40, right? What will happen is, it will check here validity first. Yes, it's greater than 0, less than equal to 100. Yes, then it'll come to this part and check, is it greater than equal to 60? No. Then it comes to else part and say fail. So that's what is going to happen. It's going to say fail. See? And if you enter less than greater than, let's say 60, like 70, right? First thing it'll do is, it'll pass the validity check. Greater than 0, less than 100, yes. Then it says is greater than equal to 60, yes. It'll print pass and not goes to else part and end it there. Look at this, pass. Here we go, see? Pass. No problem. So this is how this question is done, and that's question number what? Question number 9. Now we got a question number 10. The question number 10 is when multiple ages are recorded, it is difficult to quickly identify the youngest and oldest individual without comparison. So write a Python program that accepts 3 ages as input and determine and display the youngest and oldest, right? So that's even another very interesting question. So let's copy the solution steps, right? Somebody's gotta control the mic because there's a bit noise there. Please control your mic, whoever is noisy. Thank you. All right, here we go. We come back here. Let's do this question. Okay, so what are we supposed to do? Write a Python program that accepts 3 values. So 3 inputs, right? Not 1. So we say A is equal to input, right? 3 values, right? And then we need to compare it youngest and eldest. Enter your age. Enter age for A. Okay, let's say A. Okay, I'll put it into A, right? And this has to be an integer, by the way. Why? Because it is, or eval. You can do eval because it has to be integer, or float. It can't be float, but you can put a eval, no problem. Yeah. The second is B. Third is C, right? So I do here B. Enter the age for B because I need 3 ages, right? And then I need C. Yeah. So I just take the ages first, A. Then I do B. Then I do C. Now I got 3 ages. Then I need to determine the display the youngest and the oldest one. So how do you do that? I can use if else. If A is greater than B and A is greater than C, if A is greater than both, right? Then simply A is the oldest one, right? And then else if, let's say if A is not greater than B and A is not greater than C, then I need to check else. It's not, it means it's not a greater, right? And then I'll check if elif A is B is
greater than A and
greater than A,
C,
right? And B is greater than C. That simply means B is the greatest, oldest, yeah. B
and then you
is
can
the
write else
oldest.
C is the oldest.
What? Else C is the oldest, yeah, exactly. Else if the both are not true, then the C is the oldest. I don't need to do again else if.
Yes.
Yeah, it's simple, clear, is the oldest. Now I have determined who is the oldest, right? Now same thing I need to do who is the youngest, right? I can copy paste this. All I have to do is turn it around, same comparison. Instead of saying greater than, I'll say less than. Less than. Okay, and I would say C is A is the youngest. That's it. And same here, I change it to less than, and this one less than, and B is the youngest one. The last one is C is the youngest. Okay, and if I run this program, and that's it, I displayed it, I run this program, it will give me the right message. Look at this. Here we are. Oh, error. I always expected an error, right? Right. A, B, C. What's the error? I didn't put this this thing here. Print in front of the print. This is print. I don't need this in front of the print. Okay, this thing is not required in front of the print, and the rest is okay. Okay, so enter the age. A is, let's say, 20, B is 30, and C is 40. Who is the eldest? C. Who is the youngest? A. Let's see if it tells us or not. Here we go. C is the oldest and A is the youngest. Eldest, it should be eldest, not oldest, but it's okay. Yeah, got it? A, B, C. So this is perfect. And I'm going to move on to the next one. Yes, go ahead.
What if I enter the same number?
Oh, that's a tricky one, isn't it? If you enter two same number, it'll just take a random guess there, right? Just take a random guess. See what one is there. 40. C is the oldest and C is the youngest. Then it give you a wrong answer. If this is the exception that it has to be. The number has to be. What do you call it? Number has to be the different, right? Age has to be different. That's assumption you have to make here in this one, right? If they are same number, they'll give you different. Then you have to put a different logic. But this question, if you do that way, I'll be happy with that, all right? But if we can maybe after the major exam, we can discuss if they are equal, how to fix that problem, all right? That's another problem for maybe major 2, okay? Let's do the next one. Sensor's reading may be negative due to noise and error, must be recorded before use. So it says they need to be corrected. Sorry, must be corrected before use. So in the solution, is saying if it's negative, add 20 to it. That's it. It's not really a scientific solution, but we gotta follow the instructions, right? So let's do the instruction. It says if the sensor reading is negative, correct it before use. That's the problem we're trying to solve, and the solution it's giving us is simple. It's saying, let's say what it says. It says write a Python program that checks whether the sensor value is positive or negative. If it is positive, right, you say it is valid. If it is negative, add 20 to it and display the correct reading. I mean, we're just making an assumption that if you add 20 to it, it will be okay, but scientifically not right. But like I said, you don't need to use your brain. You follow the instructions as in the question asked. So do what the question is asking you. So if first, obviously, we need to take the sensor input, right? So we say value, VAL, sensor value, and then equal to input, and we say enter the sensor reading. Enter the sensor value, okay? Or reading, you can call it reading or value, same thing, but it has to be eval. Why? Because it could be value could be integer,
negative.
Yeah, integer or float, right? And we need to add 20 to it. So if value is less than 0, it's negative, right? Then you say value is equal to value plus whatever it is plus 20, right? And display the correct reading
val
and print print value. Val is correct.
Negative.
Val is correct. Corrected, correct or valid? Valid or correct? It says correct, we use correct, right? Correct reading is, right, comma val, okay? Else display positive value as valid, right? So else we just say valid. If it is positive, if it's not greater less than 0, then it is
valid.
You just print valid. Yeah. That's it. Now if it's less than 0, it will be added 20. So let's say if we say, oh, what the problem, we need to get rid of this. Okay, this top one, and we just enter this. It's a good method to paste the question there, huh? And then remove the question when you solved. So if it is minus, let's say 10, it will add 20 to it, so it will be 10. See, correct reading is 10. If it is, let's say, already positive, it will say whatever the value is, 2. Valid. It will say valid, not the value. Right? This one was question number what? Question number 11. And now we came to a point that everybody has been waiting for, and that is the last question, so we can get over with it. Right? And we are just 5 minutes beyond the time, but no problem. Incorrectly determined training validity may lead to unsafe design. So maybe triangle, sorry, not training. I get a problem today with my brain. Incorrectly determining triangle validity may lead to unsafe design. So what you need to do is you need to do this, right? We need to determine the triangle is valid or not. Very easy question. All you need to know is what is a valid triangle, right? That's very important. So valid triangle is where two sides are great, sum of two sides is greater than the third side. So we need to first accept 3 lengths, right? Okay.
So you can write 3 input into
yeah,
the
we can say
first,
1
the
is equal
second, and
yeah
then the third.
we can say side 1 equal to input, right?
The
Enter
first
side 1.
side
Enter
of the triangle.
side 1, okay, of triangle, or you can just say enter side 1, and then we obviously need to do eval here as well, because we need to do the comparison between them, right? Here we go. And to be quick, I just copy paste and correct it. Copy paste and correct. How do I do that then? Side 2, side 3, right? I need 3 variables, right? Side 2, side 3, and here I'll say side 2, side 3. So I got 3 sides, and now I need to do comparison, and that for validity. So if
You didn't change it, doctor.
sorry?
Change the side.
Okay, this one is 3, huh? 3. This is also 3. Okay, if side 1 is sum of side 1, if side 1 plus side
2.
2 is greater than side 3, huh?
Print valid.
Print. Well, the problem is all 3 sides has to be valid, right? Then I check, then I do a nested if again. Then do again another if that is not the case, let's go to the else part. This is a nested if problem. If that's not the case, it is invalid triangle, right?
But I think there is another way to do it, doctor.
I like this way, right?
Okay.
Okay, triangle. Let me like something as well. I spent 1.5 hours, so just do what I like. Can you do that? Fahad, are you okay
Yes.
with what I like?
Sure.
Okay. If side 1 plus side 3 is greater than side 2, right? We check that, and then we put else here, invalid. If that is failed, it's invalid, right? If that fails, it's invalid. Then the last one would be one side left, right?
دكتور
3 plus side 1.
Side
Side
2.
3 plus side 2.
Side 3 is greater than
Yes.
side 1, right? Then it's invalid. Then you can print invalid, because it has to pass all the 3 checks. Print valid, right? Else invalid, right? Like this. So this has to be nested if else, if within if. So what happens is, if you look at it, it's very simple. First you'll check side 1 plus side 2 greater than side 3. If that is true, then it check side 1 plus 3 is greater than 2. If that is true, it'll check side 2 plus side 3 is greater than side 1. Then it'll say invalid. Then it'll say valid triangle. In any event, if it doesn't pass all these 3 checks, right, it will simply go to else part and print invalid. Because look at this. For this if, this is else. This is if, this is else. This is if, this is
It's
else.
clear, doctor.
Yeah. So this is it. And with this question, we'll live happily ever after. And we run this and we check it one time. Give me a invalid triangle. For
4.
example, 4 and 3,
3,
and the third one
8.
is one
8.
is 8.
8. If you want it invalid.
Invalid 8. Oh, invalid triangle. Give me a valid one now.
4, 3, 7.
Invalid. It's still
If
invalid.
it's equal, it will be invalid also.
It will, yeah. It has to be greater.
Okay. So 4, 3, 6.
4, 3, 6. Valid triangle, and well done. And with this happy news,